So welcome to part 2 of the binomial expansion video series. In the first part, we looked at the very simple equation we can use just to expand brackets. However, one thing to note is that equation cannot be used in all cases. It can only be used when the power n is a positive value and is also an integer, okay? Such as x plus y to the power of 4. In this case, the power is 4, and it's a positive value and it's an integer, so therefore we can use the equation we learned in part 1. However, if I ask you to expand x plus y to the power of half, or even x plus y to the power of -2, in this case now our n value is no longer a positive value or an integer, so we can't use the equation we learned in part 1. And instead we have to use a new formula. And this formula can be seen here. Like the video in part 1, or the formula in part 1, it's very simple to actually use. It's just a matter of differentiating which one you should be using in each case. So let's look at an example. Let's say I want to expand 1 plus 2x to the power of -2. So in this formula it just says x here, right? But in our case it's going to be 2x. So we're going to replace this x with our 2x, and our n value is going to be -2 to the power. Once you've identified that, it's just a matter of just using this formula. So the first term is going to be 1 plus the second term, our n value is -2, right? So it's -2 times, instead of x, remember it's a 2x, okay, over 1 factorial. Next term, -2, now it's n minus 1, so -1 to this is -3 times by 2x all squared over 2 factorial. Let's just do one more term, so we get plus -2 -3. Now it's n minus 2, so it's -4 times by 2x all to the power of 3 over 3 factorial. And so on and so on and so on. And so this can go on for infinity. But in an exam, they'll say maybe find it up to the cubic term or the square term. Okay? So you're down to the all individual terms. And after we've done this, now it's just a matter of simplifying each individual term, and that way we can get our expansion. So, as I said, it's once you identify what an n value is and what the x value is, then it's very simple to use. However, there are certain cases where it could get a bit more difficult. So this equation can only be used when this value here is always a 1. It has to be a 1. If it's not a 1, then we have to slightly adjust it to make it a 1 and then apply it. So an example of this is for this kind of question here. Let's say I want to expand 2 plus x to the power of 1 over 2. First of all, we notice that, well, the power is 1 over 2 and it's not a positive integer, so we have to use the equation we learned in this video here. And secondly, it starts with a 2. Now, as I said before, if it starts with anything other than a 1, then we can't technically use it until we slightly adjust it. And the way you adjust it is trying to make it into a 1. And so what I can do is, well, to make 2 a 1, I can just divide it by 2, right? So I can actually factorize 2 out of the bracket. But note, because I take the 2 out and this bracket is raised to the power of half, this 2 also has to be raised to the power of 1 over 2. And now, inside the bracket, well, I divide each individual term by 2. So 2 divided by 2 is now 1. And I also have to divide this x term by 2. So it's going to be half x now. Close bracket, all raised to the power of a half. This is very, very important we do this. Now, because it starts with 1, now we can use the formula we just learned. So I'm going to take 2 to the power of half out, and I'm going to draw a big square bracket. And just imagine expanding this term here as we just using the equation we just learned. So I'm just going to do a cubic term. So 1 plus our n is now half. So half times half x over 1 factorial plus half minus 1 again. So it's going to be negative a half times half x all squared over 2 factorial. And the third term would be half minus 1 minus half, minus 1 again, so it's minus 3 over 2, times by half x cubed over 3 factorial plus so on. Okay, close bracket. So once we've now found each individual one, what we can do now is multiply this 2 to the power of half to each individual term. You can expand out the bracket and then simplify, and that way we get our final expansion. So key things to note. Look at the n value first. Is it positive? Is it an integer? If it's not, then we use the second equation. And also, if we do use this equation, make sure the first term is always a 1, okay? And if it's not, then we have to make sure we make it into a 1. Right, in the last video, we're going to be looking at some exam techniques and some difficult exam questions which have come out in the past, and I'm going to give you some tips to be aware of when solving these types of questions.